Welcome to our video. In this video, I will talk about our journal paper titled On Tracking Java Method with Git Mechanisms. Nowadays, version control systems are widely used in software development and maintenance, and their repositories are also useful as a resource for software engineering research. For example, fault-prone module detection and code change module identifications are typical research topics using such repositories. By using version control systems, we can easily get file-level information. However, some software engineering research requires method-level information. To easily get method-level information, Historage was developed 10 years ago. In Historage, each method in source files is extracted as an independent file. So we can easily get method-level information only by using Git command like git log. In this slide, I will talk about the file tracking mechanism on Git. In a case that there are both added and deleted files in a commit, Git checks their similarity between line-based comparisons. If the two files are more than 50% identical, the added file is regarded as a rename of the deleted file. So thanks to this file tracking mechanism, the information before rename can also be retrieved. However, the mechanism does not work well with small files. This is a motivation for this research. I will talk about our motivation in detail. This is an example commit where a file has been renamed. Person.java is renamed to engineer.java. This commit also includes changes of file field names and method names. Git tracking mechanism works well because there are only several lines of changes to the entire file in this case. But in case of Historage, which means each method is extracted as a file, the file cannot be tracked with the file tracking mechanism because there are many lines of changes to the entire file. Our key idea to resolve this problem is simple, just increasing the number of lines, which means placing only a single token on each line. If the files follow this format, Git tracking mechanism works well because there are only several lines of changes to the entire file. We conducted a preliminary experiment for the key idea. We confirmed that many methods can be tracked longer with the key idea, but there were also many long tracking. The cause of this problem is the similarity of unrelated methods exceeds the threshold. So we try to avoid tracking unrelated methods by introducing two heuristics. But due to time limitation, in this presentation, I will explain only one heuristic. This is heuristic one. Dominant factor of long tracking is that parentheses and semicolons of different program elements were often matched. To resolve this problem, we subdivide parentheses and semicolons according to the types of program elements. In our heuristic, semicolons are subdivided into 17 types and parentheses are subdivided into 19 types. Here is an example. Left-hand code is a deleted method, which includes an if block. And the right-hand code is an added method, which includes a while block. These two methods are unrelated, so lower similarity between two methods is better. If we does not use heuristic one, the lines, including parentheses, brackets, and semicolons between the two methods are matched accidentally. And these accidental match raises the similarity between the two methods. However, if we use heuristic one, subdivided token types are added to each line like this. So as a result, no line matches between the if block and the while block. We have implemented our key idea and the heuristics as a software tool, FinerGit. If you are interested in our technique and you need method level information and on your research or job, please try our FinerGit. Feedback is very welcome. This is a journal paper, so we have evaluated our proposed technique from several points of view. This slide shows a summary of the experimental result. Finite F measure in the best case was 84%, while histology F measure was 70. And we confirmed that finite tracked more renames than histology in 170 out of 182 target projects and for methods of any size. And the repository construction time of finite was about 100 seconds per 10 kilo commits. And that's all. Thank you very much.